We have been told that we are using 340 grams. One is the trial and error balancing approach. For some people, trial and error works very well. They just keep guessing and figure it out. Okay. I used to be really bad at trial and error. So then I finally found out that we can use fractional approaches to solve problems, and that was a lot simpler for me because that's very systematic, just step by step I just need to apply. Then there was a problem because next step when we got to questions which required more complex balancing, even the people doing trial and error would struggle. And fractional approach started to become a little messy. So then I added one X to it. So we have the algebraic approach to solving problems. Okay, but let us use this fractional approach. Fractional approach is very straightforward. Start off with whatever looks like the most complex molecule. O2 and all just has O, this one has N and it has H. So I'm going to start by making this 1. If you don't have anything in front, it is not 1. It just simply means dash. Now this is 1 NH3. Only one number you start with 1. How many N's does it have? 1. So that means there is no other N anywhere else, right? So this must be 1. And N is now balanced. And there are how many H's? 3. That means this must have a total of 3 H's. But it has 2. So it must have 3 by 2 H2O because that is equivalent to 3H. I know that you cannot have 3 by 2 H2. Right? You can't have 3 by 2 H2O. It's not possible. But right now we are just balancing it mathematically. That's all. Because we will finally multiply by the LCM. So 3 by 2 H2, clear? So that means the H is also balanced. Now that is over. But if you come here, how many O's do you have? I have 3 by 2 O's. How many O's do I have here? 2. So totally I have 7 by 2 O. But you see, I need O2. So I must have 7 by 4 O2 because 7 by 4 O2s is equal to 7 by 2 O. You know it can't exist like this, but it doesn't matter. It's only mathematical right now. So therefore, this is 7 by 4 O2. Is that okay? So that means O's are balanced, N's are balanced, H's are balanced. So this is a balanced equation, except this kind of a reaction makes very little sense because you can't have half a molecule. But that is very easy to correct because you take the LCM for the entire thing. What is the LCM? 4. Multiply by 4. Everything, all the denominators will basically go away. So multiply by 4, what will happen here? This will become 6. Multiply by 4, 4. Multiply by 4, this becomes 7. Multiply by 4, this becomes 4. So therefore, the actual balanced reaction is this. Okay. So which means 4 molecules of ammonia reacts with 7 molecules of oxygen to produce 4 molecules of nitrogen dioxide and 6 molecules of water. This is actual reaction that happens. I hope that is okay. Now, if I had 4 molecules of ammonia, 1 molecule of ammonia has how much mass? 14, 15, 16, 17. So this is 17. 17 into 4. 68. So this will be 68 grams of ammonia for 1 mole. If I think of this not as 4 molecules but 4 moles, 7 moles, 4 moles and 6 moles, then I can convert everything to mass. 68 grams of ammonia will react with 7 moles of oxygen. One oxygen molecule has 32. 32 into 7. How much is that? 224 grams of oxygen. And then you have 4 molecules of nitrogen dioxide. If I take a mole, that means 4 moles of nitrogen dioxide. 32 plus 14. How much is 32 plus 14? 42 plus 4, 46. 46 into 4. 184 grams. And if I look at this, this is 18 into 6. Okay, so that is 18 into 5 will be 90. 90 plus 18 is 108. So this is 108 grams. Quick check. Does this and this mass-wise add up to this and this? How much are those two together? 184, 108, that is 284 plus 8, 292. So totally this is 292 grams. These two together is it 292 grams? 200 plus 220 is, that is going to give me 288 plus 4, 292. So this is 292 grams. Okay. Now if that wasn't the case, something is wrong. What is this telling us? This is telling us if 1 mole of the whole reaction happened, not 1 mole of each object. 4 moles, 7 moles, 4 moles, 6 moles. So we call this a molar reaction. Everything just take the molecule numbers and call it mole. But that is not the actual reaction that happened. The actual reaction started with 340. 68, 340. What is the connection? Into 5. So that means you multiplied this by 5. You should multiply this also by 5. So that means it must be 224 into 5. 1120 grams. 184 into 5. 920 grams. 108 into 5. So that means when the reaction happened with 340 grams of ammonia, how much water was produced? 540 grams of water was produced. The question may not say find everything. The question may say to have a reaction with 340 grams of ammonia completely reacting, how much oxygen do I need? Answer is 1120 grams of oxygen. The question may not ask you this. The question may not ask you everything. The question may just ask you what is the total mass of oxygen that you need for this reaction. What is the total amount of nitrogen dioxide produced? 920 grams. Is the idea first clear to everybody? How this works? Right? So it is just a matter of proportionality. You can also do this in a slightly different way. You can say 4 moles, I know it is 68, but I want 340 grams. 340 grams is 17 into 20. So I must have had 20 moles of this, which means I must have had 4 into 5. So I must have had 20 moles of ammonia. So I must have 7 into 5, 35 moles of oxygen. I must have had 4 into 5, 20 moles of nitrogen dioxide. And I must have 6 into 5, 30 moles of water. What is the mass of 20 moles of ammonia? 340 grams. What is the mass of 35 moles of O2? 35 into 32. How much is that? 70 into 16. I think that is this. 16 times 7 is 1120. Suppose I say I have 30 moles of water. What is 1 mole of water? What is the mass? 18. 18 into 30, 18 into 3, 54, 540. You can directly go to this, you don't have to even calculate this. Because this tells you that you had 17 into 20 grams of ammonia, which means you must have had 20 moles of ammonia. But 20 moles of ammonia, for 4 moles, you had 6 moles of water. So for 1 mole, so you can also argue like this. 4 moles of ammonia produces 6 moles of water. 20 moles of ammonia will produce 30 moles of water. The proportionality is for moles. It is not for mass. Once you figured it is 30 moles of water, how much will be the mass? 30 times 18. So 540. Hopefully this is clear. Okay.